Another feature of Tesla Bot Gen 3 has been confirmed by Elon Musk. As the launch date draws closer, the picture of the new Optimus version is becoming increasingly clear. This time we'll have an Optimus model with surprisingly strong water resistance. This further proves that Jason Calacanis' assessment of Optimus 3 is not exaggerated at all.
And I saw Optimus 3. I could tell you now, nobody will remember that Tesla ever made a car.
What do you think about Optimus being able to perform water-related tasks such as washing dishes, watering plants, rinsing food, or even bathing pets? Okay, it may sound like science fiction, but given what's been leaked about Tesla's design improvements and new technologies, this idea is entirely plausible. This could very well become a standard feature before Optimus is put into real-world use. You know, without water resistance, it would almost fail at most tasks. It could short-circuit or shut down if it were caught outdoors in the rain. Clearly, integrating water resistance into Optimus 3 not only expands its range of applications from factories to outdoor environments, but also serves as a strong statement about the durability of this version. So how will Optimus achieve water resistance, and why does this feature completely change the game? Let's dive into the revelations from Elon Musk. Recently, in a post on X, when Elon Musk was asked about Optimus's water resistance, the Tesla CEO revealed that it will more or less have this capability. Although he didn't go into detail, the brief yet suggestive response immediately sparked heated discussions across the global tech community. Many people are now wondering, how will Optimus be waterproof? Can it wash dishes? Will it know how to wash its hands? Yeah, there are a lot of questions. Previously, Elon Musk repeatedly stated that Tesla's robot could do anything humans ask of it, including tasks it has never performed before. According to him, users wouldn't need to manually train the robot because Optimus is capable of learning on its own and completing tasks accurately. However, in reality, even the simplest tasks require Optimus to be highly durable and able to operate reliably across a wide range of environmental conditions. The robot doesn't need to be fully waterproof, but at a minimum, it must meet a solid water resistance standard to function in damp environments or harsh weather such as rain and snow. This is precisely the limitation of Optimus 2.5. Despite its impressive design, this version still lacks full water resistance as many actuators and joints remain exposed. As a result, Tesla is essentially forced to redesign the robot for Optimus 3 version with protective coverage that's almost like wearing a raincoat over its entire body, aiming for a more complete and durable design. To understand why this feature matters so much, we need to look directly at Tesla's goal, turning Optimus into a household assistant robot. In everyday living environments, water is almost everywhere, sinks, bathrooms, puddles, or simply rain when the robot moves outdoors. These are all perfectly normal situations, but they can pose serious risks to a complex electronic machine. Without sufficient water resistance, a robot worth tens of thousands of dollars would be forced to operate within a very limited scope, constantly having to avoid water and moisture. That makes it extremely difficult for Optimus to handle household tasks in a reliable and safe way. Honestly, even if Optimus really were priced at $20,000 without water resistance, it would be almost useless. That's why water resistance isn't an optional upgrade, but a basic requirement for the robot to function long-term in real human living environments, rather than being suitable only for demos or laboratory settings. Look at the evolution of some of the most iconic tech devices. You know, early generations of the iPhone were completely afraid of water, but today an IP68 rating has become a must-have standard. For a complex robot like Optimus, this challenge is exponentially greater. In its early versions, Optimus fully exposed its wiring circuit boards and actuators. Aside from making it look like a research project, those versions would certainly fail if even a single raindrop fell on them. However, as you can see in the latest versions, around 70% of Optimus's body is now covered with engineered plastics and advanced polymers. This design not only optimizes weight, allowing the robot to move more flexibly and perform smooth actions like dancing or jogging, but also creates a natural protective layer against corrosion. That said, the Achilles heel of any humanoid robot has always been its joints, and especially its hands, where the most sensitive electronic components are concentrated. Recently, images of Optimus's new generation hands with 22 degrees of freedom have revealed a major mechanical breakthrough. Compared to earlier versions that exposed cables and actuators, the new hands appear to be covered by a seamless elastomer membrane, functioning like a protective glove. This tightly sealed design not only provides comprehensive water resistance, but also seems to incorporate antibacterial protection layers. Of course, this is still speculation, but fundamentally it's a necessary safety measure when Optimus is expected to perform real-world tasks. Just imagine the concern of a homemaker seeing a robot that has just cleaned the bathroom or bathed a pet immediately reaching out to handle food in the kitchen. Oh my God, that's truly horrifying. Elon Musk's vision for Optimus isn't just about what it can do, but where it can do it. A robot capable of washing dishes, watering plants, mopping floors, or even bathing pets requires a near-perfect electromechanical system. From an engineering perspective, waterproofing the hands alone accounts for nearly half of the total engineering effort across the entire robot. That's easy to understand since the hands are the components that interact most directly with water and cleaning chemicals. Tesla's decision to fully seal the actuators and move them up into the forearms not only makes the hands slimmer, but also creates space to isolate and protect the electronic circuits from moisture. In addition, Optimus's power system is likely to inherit Tesla's expertise from its electric vehicle lineup. The robot's battery pack will probably be designed with a sealed structure similar to that used in Tesla EVs, preventing water from penetrating the battery cells almost entirely. This ensures that even when operating in high-humidity environments, the robot's energy source remains safely protected. This capability also unlocks enormous potential for outdoor operation. Optimus could function in snowy conditions, carry items in light rain, or stand guard over your home without worrying about the weather. Reliability is the deciding factor in the success or failure of any mass-market technology product. No one is willing to pay a large sum of money for a robot assistant that they then have to take care of by shielding it whenever it rains or drying it off every time it accidentally comes into contact with water. By prioritizing water resistance and antibacterial protection right from the final production stage, Tesla is proving that it's not just building a machine that mimics human actions, but creating an entity that can truly exist and adapt seamlessly within human living environments. Water resistance also delivers a major economic benefit for users' reduced maintenance costs. Water and humidity are the #1 enemies when it comes to oxidation and short circuits. A tightly sealed system extends the lifespan of internal mechanical components, allowing Optimus to operate reliably for many years without the need for major overhauls. This is especially important as Tesla aims to bring the robot's price below $20,000, comparable to a low-cost car, but with far greater everyday utility. Although it was simply a confirmation of one feature of Optimus, 3 Elon Musk's comments about its water resistance actually reveal a great deal about how practical this robot could be. While there have not yet been real-world tests, the way Tesla is refining the design suggests that Musk is taking this very seriously. At the World Economics Forum 2026 held last week, Elon Musk offered the clearest look yet at the future of humanoid robots, addressing the question the entire world has been waiting for. When will we be able to own a Tesla bot? Despite his reputation for overly optimistic timelines, Musk's remarks this time pointed to a well-structured strategy starting with rigorous testing in factories and ultimately aiming to make Optimus a companion in every household. As officially confirmed, Tesla Bot Gen 3 will launch later this quarter, marking its first commercial version. At present, Optimus is handling simple tasks inside Tesla factories, but Musk believes that by the end of 2026, these robots will be capable of taking on far more complex tasks.
Humanoid robotics will advance very quickly. I think we do have some of the Tesla Optimus robots doing simple tasks in the factory. We expect probably later this year. By the end of this year, I think they'll be doing more complex tasks.
However, instead of releasing it to the public right away, Tesla will spend all of 2026 deploying Optimus internally. This is seen as a large-scale real-world trial aimed at collecting data on environmental perception and decision-making in unexpected situations. It won't be until late 2027 that Optimus is officially made available to the public.
By the end of next year, I think we'd be selling humanoid robots to the public. That's when we are confident that it's very high reliability, very high safety, and the range of functionality is...
Musk explained that introducing an autonomous robot into human living environments is far more difficult than manufacturing cars. It requires an almost absolute level of safety, reliability, and predictability. In addition, mass production presents a major challenge since most of the core systems in Gen 3, from the dexterous hands to the AI-5 hardware, are completely new designs. The most striking point in Musk's speech wasn't about productivity, but about the human role of Optimus. In the context of a rapidly aging population, Musk sees elderly care as a necessary and highly meaningful application for the Tesla bot. For example, Optimus wouldn't just assist with mobility or medication reminders. It could also act as a companion, helping to reduce loneliness, one of the most serious challenges of old age.
If you had a robot that could take care of and protect an elderly parent, I think that would be great. That would be an amazing thing to have. I think everyone on Earth is going to have one and going to want one, because who wouldn't want a robot to, assuming it's very safe, watch over your kids, take care of your pet,
Not stopping there, Musk believes that every household will want to own an Optimus to look after children or care for pets. The robot would serve as an at-home tutor for kids, providing peace of mind and giving parents more time to focus on their work. He emphasized that these household robots will be governed by hardware-level safety mechanisms, ensuring that humans always retain ultimate control. Notably, Elon Musk made a bold prediction that by 2026, AI could surpass human intelligence, and by 2030, it could become smarter than all of humanity combined. In such a world, work would become a choice rather than a necessity. However, this vision has not been without controversy. Musk himself acknowledged that he is often overly optimistic about timelines, while also warning about the real risks posed by AI. He cautioned that we must be extremely careful not to turn the future into a Terminator movie. Ending the conversation, the billionaire chose to remain optimistic, believing in a brighter future where humanity is wise enough to stay in control of the technologies it creates. Recently, Tesla also resets timelines for Cybercab and Optimus as it builds key technology in-house. Tesla's Cybercab robotaxi and Optimus humanoid robot represent two of the most ambitious bets the company has ever made. So when CEO Elon Musk recently acknowledged that early production in 2026 will be agonizingly slow, criticism quickly followed. To many observers, slow production sounds like missed targets or execution problems. Inside Tesla, however, the story is very different. What looks like delay from the outside is in reality the result of deliberate engineering and manufacturing choices made to ensure these products can eventually scale to unprecedented levels. Cybercab and Optimus are not evolutions of existing Tesla products. They are entirely new platforms built from the ground up. As Musk explained, for Cybercab and Optimus, almost everything is new, so the early production rate will be agonizingly slow but eventually end up being insanely fast. That distinction is crucial and often lost in headlines. Tesla is not simply refining an assembly line or iterating on a familiar vehicle architecture. It is simultaneously developing new hardware, new software, new supply chains, and entirely new manufacturing processes. Musk has repeatedly emphasized that Optimus in particular is a hard problem in engineering design, and especially manufacturing. The challenge is not just making a robot that works, but making one that can be produced reliably, affordably, and in massive volumes. Early in Optimus development, Tesla ran into a fundamental obstacle. Many of the components it needed simply did not exist at the required quality, reliability, or scale. Rather than waiting for suppliers to catch up, Tesla made a decision it has made many times before with batteries, power electronics, and manufacturing automation. It chose to build key components in-house. This choice inevitably slowed early production, but it laid the foundation for long-term scale. Vertical integration gives Tesla control over design cost, reliability, and future production speed. Elon Musk himself has been deeply involved, even spending every Saturday for several months working on the AI-5 chip, which he has described as existential to Tesla. That chip is central not only to Optimus, but to autonomy as a whole. Progress is already visible. Optimus robots are performing basic tasks inside Tesla factories with more complex functions expected by the end of the year. Low-volume production began in 2025 for internal use, while mass production of the third-generation Optimus is targeted for 2026. Public availability is now expected in 2027 once Tesla is satisfied with reliability and safety. Cybercab faces a similar set of realities. Designed for full autonomy, it has no steering wheel or pedals. This means it cannot rely on incremental improvements to today's vehicles. It requires a purpose-built platform, a new safety architecture, and alignment with regulators. A major milestone was reached in January 2026 when Tesla began unsupervised robotaxi drives in Austin with no safety monitor in the vehicle. Autonomy is also constrained by hardware availability. While software can improve rapidly, the global supply of advanced AI and automotive-grade chips remains tight, affecting the entire technology industry. Tesla's investment in in-house AI hardware, including the AI-5 chip, is intended to reduce this dependency. Musk has noted that AI-5 will be both very capable and cost-effective at scale. Meanwhile, full self-driving continues to advance quickly. The system is updated frequently, and supervised robotaxi trials are already underway in select cities. The transition from supervised to unsupervised autonomy is not a marketing switch, it is a major engineering and regulatory leap. Musk has confirmed that Cybercab production line testing is already in progress with a true production ramp beginning in April 2026. Critics often compare Tesla to companies like Waymo, but the comparison misses a fundamental difference in approach. Waymo operates in tightly mapped geofenced areas. Tesla is pursuing a vision-based system designed to work everywhere without prior mapping. That approach takes longer to solve, but once achieved, it offers far greater scalability. Earlier production targets shared by Musk reflected end-state ambitions, not the messy reality of building entirely new industries. As development progressed, Tesla chose to slow early output in order to redesign components, improve reliability, and bring critical technologies in-house. Musk has consistently described production as following an S-curve, slow at first due to novelty, then accelerating exponentially. This is not new for Tesla. The Model 3 ramp, the 4680 battery program, and even early Model S production all experienced similar phases where initial timelines gave way to deeper engineering work that later enabled massive scale. The slower early ramp of Cybercab and Optimus does not signal a collapse of plans. It signals that Tesla is choosing to build the foundation properly before scaling. Current targets point to Cybercab mass production in 2026 and Optimus reaching the public in 2027. Ultimately, Tesla is not treating Cybercab and Optimus as experimental side projects. It is treating them as future core products engineered to the same level of control, reliability, and scalability as its vehicles. That process takes time, but once complete, it enables exactly the kind of rapid production Tesla has become known for. Optimus Gen 3 is more than just the next version of the Tesla bot. It represents a fundamental shift in how we think about machines, labor, and everyday life. For the first time, Tesla is not presenting a humanoid robot as a controlled demo or a research experiment, but as a system designed to operate independently in the real world. Full autonomy is the defining breakthrough, and it is what separates Optimus Gen 3 from everything that came before it. If Tesla succeeds, the implications are enormous. A robot that can walk, naturally manipulate objects with human-level dexterity, learn new tasks from videos, and work for hours without fatigue changes the economics of labor itself. Tasks that are repetitive, dangerous, or simply undesirable for humans could be handed off to machines that never get tired and continuously improve through shared learning. This isn't about replacing people. It's about freeing human time and attention for creativity, decision-making, and innovation. At the same time, Optimus Gen 3 forces us to confront difficult questions. How do we integrate autonomous humanoid robots into homes, factories, and hospitals safely? How do we protect privacy, security, and trust when machines can move, see, and act on their own? And how do societies adapt when productivity is no longer limited by human endurance? Elon Musk's vision that work could eventually become optional sounds radical today, but so did the idea of self-driving cars or reusable rockets not long ago. Optimus Gen III may not fulfill that vision overnight, but it clearly points in that direction. What matters most is that humanoid robots are no longer science fiction. They are becoming products, workers, and companions in the physical world. Whether Optimus Gen 3 ultimately succeeds or falls short, it marks the beginning of a new era, one where intelligence finally gains a body, and humanity must decide how to live alongside it. So if Optimus were affordable, would you personally buy or rent one for your home or business? Thanks for watching. Drop your views in the comments, join the discussion, and don't forget to subscribe for more deep dives into AI, robotics, and the future of technology.